any point. If you have any questions for myself or for our host, feel free to type them in that chat box or the Q&A section, either one. And we will dedicate probably the last 5 to 10 minutes of our presentation to answering any questions that you guys might have. So there's that. And a little bit about inoLECT, if you don't know, that we are an electrical engineering company out of Baton Rouge. We specialize in arc flash solutions. We have a team of highly skilled engineers that perform incident energy analysis, remediation, relay retrofits, power factor correction, things of that nature. And joining us today, our host is going to be our vice president of that department, Daniel Brignac, who is a professional engineer and been with our company for about 12 years now. So he's our resident expert on protection retrofits, and we're very fortunate to have him as part of our team. Like I said, if you have any questions for Daniel or for our team, please feel free to type them in at any point during our presentation. And with that being said, I will give it over to Daniel. Daniel, you ready?
Thanks, Mindy. Appreciate it. As Mindy said, my name is Daniel Brignac here at inoLECT, Vice President of Engineering. And I just wanted to talk to you guys today a little bit about protection retrofits. A variety of reasons to do this. One, maybe you have some obsolete electromechanical relays in your facility that you're looking to upgrade. Maybe you don't have the documentation or have the proper features in some existing relays that you're also trying to upgrade. Or maybe you just can't perform the maintenance while the system's online or offline like you'd wish to. So with that being said, we'll get started talking about some protection retrofits here. A little bit of an agenda for today. We'll go over a brief introduction. We'll talk about some sample photographs, some product photographs, scope of work, typical schedule, some different proposal requirements, because a lot of times we get asked to provide a proposal, but we want to make sure that we're providing everything in accordance with your expectations. Some proposal evaluation questions, some budgetary estimates, and then finally some reference projects. So here at inoLECT, we have a project sponsor that's always going to be a licensed professional engineer in whichever state that your facility is located in. The project lead engineer / manager is always a licensed professional engineer, and he is always on site for installation to answer whatever questions may come up, either via from our internal team or from the customer's team on site. All of our project team has a specific experience in protection systems, testing, installation, etc. We use a wide variety of engineers whenever we go out there, and they actually engineer what we install. We have a long history of successful protection system retrofits, and we focus on system upgrades versus in-kind replacements. We try to enhance your system and give you additional capabilities versus just doing an in-kind replacement. One thing that we do want to point out is a lot of times we get asked to compete against different projects. Sometimes those competitors, they may have a design team that might have an engineer on it, usually just has a designer. From an installation standpoint, we see a lot of times technicians are on-site, electricians, and they're remotely supported either via phone or some kind of, iPhones have this new feature where you can all video chat together. So they'll have remote support that way. And they're usually a jack of all trades. They don't necessarily just specialize in protection system. And they usually do a standalone philosophy focused on just replacing in kind. One of the things that we do here is, like Minnie mentioned during the introduction, we specialized in best practices and high quality with in-depth knowledge related to arc flash reduction and advanced tripping and control schemes. Our panels are custom fabricated, they're laser cut, and they're powder coated to match the existing color scheme. Demolition, installation drawings are typically developed in AutoCAD format, and we have custom relay configurations along with full text descriptions to aid in knowledge of relay operations, maintenance, and event analysis. You know, what we typically see from competitors might be steel panels that are unpainted, drawing markups that are red line for you to scan into your drawing-based system. And a lot of times what we see whenever we go behind people is they have default relay configurations. And that leads to additional time required for maintenance and event analysis because it's not clear exactly what protection features those relays are providing. We also perform system studies in-house. That includes updating ETAP, SKM, Easy Power models, performing incident energy analyses or arc flash results, and protection time current curves. A lot of times we don't see that happening, so we want to make sure that people understand that that is a feature that can be offered if needed. On this screen, it's just a little bit of a slide showing a general project flow. Mindy mentioned we are an engineering company, so we try to come on site and be on site for a minimal amount of time, fully prepared to do what we need to. If you look on the left-hand side, we'll have a power system study where we look at what's going on in your system and make sure that we're putting in the right type of protection features that you need to accomplish your goals. We do an approval drawing package along with procurement, in-house assembly, in-house testing, and then after all of that is done, we come on site and perform installation and testing along with startup. What we typically see a lot of times whenever people just call up out the blue and they ask for a protection retrofit, a lot of places they'll do procurement, they'll immediately get started without looking at what is needed to maybe enhance your system or provide you additional benefits. They'll move to panel assembly, and then while they're on site, they're actually doing the panel assembly. They bring a box of relays with wire and lugs, and they do full assembly on site. And they also, that's their first time looking at drawings and performing markups and testing. A lot of times we don't see a power system study being done to make sure you meet your needs in arc flash incident energy reduction possibly, or an approval drawing package where you get a chance to take a look at the system, take a look at the nameplates, the test switch layout, et cetera, and make sure that it meets your needs. So a sample project that we'll go through here is a generator. This one consists of a generator protection retrofit. It also included a main transformer, an auxiliary transformer, and a digital fault recorder. This was at a generating station for a customer in North Carolina. It was about $350,000 total install cost. And just so you can see, day one was basically packing up at our shop and unloading at the customer's facility. On the left-hand side, you can see how we transport some of our relays. We ship them in panels that are prefabricated with the relays fully hung, terminated as much as possible. Everything on those panels is pre-terminated, pre-landed. It's got wire labels on it showing to and from wire destinations. And it's also mounted in secure racks for transportation. That way it doesn't get jostled or damaged during transport to the facility. And you can kind of see through some of these pictures where we mount them on our panels, where we hang them whenever we go to put them in the trailer. And then on the far right-hand side is a before picture of the customer's facility. You can see there's a whole bunch of older equipment in there, electromechanical relays, and very limited fault location, fault disturbance analyses capabilities in those relays. A lot of times, all you have is just a little flag and it tells you that it tripped. But whether it was the primary cause of the trip, what phase it actually was on, how long the event duration took, whether the relay was supposed to operate even, cannot be determined from that because all you have is just a flag. Day two, basically, we got everything completely demolished at the customer's facility. On the left-hand side, you can see the new panels are fully installed. They have the blue tape above, what we used to identify which panels we were working on, just to make sure that we didn't get into a situation where we were working on something we weren't supposed to. And as you can see, we basically covered up the entire front faceplate with the exception of some meters and existing equipment that the customer didn't want to be removed due to issues with the transmission crew and how they meter in the facility. And in the back, you can see the kind of wire whips that we have. Day number two, I usually say it looks like a bunch of spaghetti on the inside. Doesn't really look that nice, but once we get done, you'll see a final picture and you'll be able to see the final quality. So day two, we basically got the panels installed and we left the day with wire whips hanging in the back. Took us a few days to get everything fully wired up and fully installed. So we got day two, day three, four, and the end of day five, we got completely done with wiring. So these were full height panels. Because we came in, we had a full add delete list that we were able to work off of. So while we're doing the demolition, we're not looking at any drawings whatsoever, unless there is a major issue with what we expected to find. You can see new terminal blocks have been installed, all the wiring's been installed and tie wrapped in place, and wire labels and everything have been installed too. After we did the relay retrofit, we took day 6 and part of day 7, and we basically went through and we pushed all current sensing. We basically pushed current through the entire system. We injected voltage throughout the system. We tripped every device. We rolled every lockout, made sure that all the inputs were getting the proper signals from the customer's equipment, and went through the full testing regimen. And by the end of day 7, we basically had the trailer fully packed up and we were ready to come home. So this was a full retrofit that consisted of generator protection and 2 big, 20 MVA, 500 MVA transformers being retrofitted, along with digital fault recording that we were able to complete on site in 7 days due to the amount of upfront time that we put on. This is just another example, kind of a similar retrofit, where we had a customer, again, they had some electromechanical relays that they wanted to get rid of. We went in with some full height panels. In this instance, they elected not to color match the scheme, and they wanted to go with ANSI 61 gray panels, which is what we did. Just another example, this one's of a simple feeder retrofit where the customer wanted to keep the amp meter, and we actually replaced that with a newer amp meter that they had in storage that still worked. Another example of a before picture. This again was at a generating facility. You can see the older electromechanical relays there on the left. They had a bunch of wire, no wire labels. It was really hard to tell where everything was going. Made it extremely difficult from a troubleshooting perspective. And then whenever we got done, there was a significant amount of equipment that we added to this system. And we were still able to keep it relatively neat and clean and make it easy for them to troubleshoot if they ever needed to in the future. So a typical scope, and one of the things that we want to point out, as many mentioned earlier, we are engineering companies. So we're primarily focused on doing the engineering upfront, getting the project in accordance with your expectations. Whenever we come on site, we're trying to minimize the amount of time that we spend looking at drawings, demoing a bunch of wire. So we do a bunch of things up front. And we also want to provide a full service where a lot of times you may call and say you want a protection retrofit. Well, if you're maintaining a power system model in ETAP, SKM, Easy Power, for instance, a lot of times what gets retrofitted does impact your arc flash. So one of the things that we typically do is we update your power system model. We update your protection time current curves, reperform the incident energy analysis or arc flash, and give you the results. And then we use that to base the relay settings calculations on to make sure that it meets your needs. We also develop an approval drawing package. That approval drawing package has full equipment elevation drawings and equipment elevation demolition drawings. Make sure that equipment that we're taking out matches the equipment that you want to get put in. Relay one-line diagrams and relay one-line demolition diagrams, AC schematics, AC demolition schematics, DC schematics, DC demolition schematics, connection diagrams showing point-to-point wiring, and connection demolition drawings, again, point-to-point wiring that's being taken out, along with any interconnection diagrams and interconnection diagram demolition drawings. We also do a complete bill of materials showing you all the equipment that's being added, full part numbers and manufacturing. The custom relay settings configuration includes a text description of the detailed relay operation, including how those relay elements are set, how all the inputs operate, how all the outputs operate, along with any and all IEEE standards that are used in developing the relay settings. A lot of times if you call someone out the blue, a lot of these items aren't provided. It's typically a limited approval drawing package just showing what was installed, which can lead to issues whenever you go out in the field and you actually try to start demolishing it, and maybe it doesn't match what you expected to see, or if you get a third-party contractor to do the installation and they start trying to demolish and it doesn't match what they're expected to do. From a procurement standpoint, we procure all equipment materials required to ensure a complete working system after the approval of the approval package by the customer. A lot of times we get asked why we don't order equipment immediately up front, and a lot of times that has to do with we just want to make sure that we are providing the correct equipment for your installation. For instance, a lot of relays come with options to have 48 volt DC, 24 volt DC, 120 volt DC or AC control power supplies. or input voltages. And we want to make sure that we match your system. We've been asked quite frequently in the past to provide 120 volt DC, 125 volt DC power, and we get into the drawings and we find out that it's really a 48 volt DC system. And those two are just not compatible, unfortunately. Requires going back to the manufacturer, getting new cards for the different relays, or possibly in some cases you have to send the entire relay back to the manufacturer, and that can lead to a long delay. Equipment can include protection relays, variety of manufacturers out there, test switches, lockout relays, any terminal blocks for new wiring that needs to get installed, along with CT shorting blocks and fuse blocks, along with the fuses that go with those fuse blocks. Relay cover plates, relay mounting plates, doors, and protection enclosures in some cases where an entire new panel is desired. Materials a lot of times include SIS wire, wire labels, tie wraps, ring lugs, miscellaneous screws, nuts, bolts, etc. as required to get it installed. From an installation standpoint, as I mentioned earlier, we like to develop complete wire add and delete lists. What that enables our engineers out in the field to do is they basically put the drawings over to the side and allows them to go wire by wire, and we start at one end, we determinate it or cut it depending on the application that's required. We follow it to the end device, and then we make sure that it matches our delete list completely. If it doesn't, we stop, we flag it for the lead engineer to take a look at, and he can keep on working doing the demolition while the lead engineer figures out what kind of changes may need to be made to the design. We also provide all tools, labor, and equipment required to ensure the complete working installation. Lead engineer should be on site for the duration of the equipment installation, testing, and startup. You never know what kind of issues you can encounter. Maybe you get out there and there have been some significant changes in the system since it was installed. Maybe the drawings haven't been updated, systems have been commissioned and decommissioned multiple times, etc. Wiring shall be neat and orderly whenever we install new labels, new equipment. All the wiring back to the next point of termination is all new. Sometimes people go in and they just clip the wire, relug it, land it back on the new device. That can lead to some issues later on down in the field where you're trying to troubleshoot or do some event analyses and it doesn't match what it should from a design standpoint. Wiring terminations get identified by a flame-resistant heat shrink conductor identification sleeve showing the local and remote opposite end. And what that allows you to do is quickly and easily troubleshoot by not having to pull out the drawings. You can look at the wire, look at the wire label and see exactly what it's supposed to be landed on. And then you can see exactly where it's supposed to go. So if you're trying to troubleshoot, you don't have to pull out the drawings and start trying to figure it out. You can look at the label and immediately put your meter on where it needs to go. Terminal blocks, terminals, conductors, relays, fuse blocks, and other devices permanently labeled, be that with a phenolic tag that's sticky back. They do stick on. You can use some silicone to keep it on there if you like, or sometimes customers like them to be applied with set screws. Another thing that is suggested is to do front nameplates directly above all test switches, identifying the test switch function, for instance, voltages, currents, breaker status, trips, etc. for each individual test switch, again, trying to minimize the time that a technician would have to pull out a drawing to be able to isolate whatever he needed to isolate or to do troubleshooting or testing. Conductors terminated with ring-tight pre-insulated indent compression lugs. What happens a lot of times is if you use fork terminals and you try to put more than one lug on that terminal and you have forks, those can become very easily loosened and they can fall out. Using the ring type ensures that you make a solid connection and it gets tightened down properly. Splices, as I mentioned, you typically would like to take the new wire that's going in and completely pull it back to its termination point versus trying to splice it in the middle. A lot of times if you put more than 2 wires per terminal, it ends up making the screw not be able to turn down tight enough, and you end up having connection problems and you end up with inconsistent operation. Wire by wire demolition and documenting any discrepancies. This comes into play whenever we're trying to verify the design of the system before it gets fully installed, make any necessary changes while we're in the middle of the installation, versus at the end where we're trying to do startup and you may be starting up a generator or a motor or a transformer and the system doesn't operate properly or fails to operate. From a protective device bench testing, we recommend that test equipment be calibrated within the past 12 months. For instance, you hear Omicron, you hear Doble, you can hear Mega. Those are some common manufacturers of relay test equipment. It's recommended that you get those calibrated. They do drift over time. If provided by the customer, review the configuration files for alignment with the design. For instance, whenever we get relay settings from somebody, in common issue is on transformers, where you have a phase shift from the primary to the secondary. If the relay settings don't properly match that phase shift, you could have inadvertent operation whenever it gets started up. The relays are set according to the approved relay settings document. Relay analog to digital conversion through secondary injection tests for each CT and PT input. And we test relay inputs and outputs to verify correct operation. We also recommend that you function test the relay program protection elements and verify the element pickups and timing set points. That ensures that it's set in accordance with the system design. And also perform all manufacturer recommended tests. From an assembled sub panel before we go out in the field, we recommend that you have that panel manufacturer perform point-to-point checks to minimize troubleshooting or miswiring in the field that could cause other issues. From a post-installation standpoint, it's recommended to measure, document, and confirm the magnitude and phase angles of all modified current circuits by injecting current on all those circuits and measuring the current in each device. Depending on your application, you may want to go all the way back to the current transformer in the system, or you may choose to decide to go back to the next closest location that was unmodified within the system. From a voltage standpoint, measuring, documenting, and confirm the magnitude and phase angle of all modified potential circuits by injecting secondary voltages on those circuits and measuring it in each device. And then operate, document, and confirm every trip, close, block signal on all modified circuits to verify a complete working system. For instance, you may have a single contact that you modified in the trip circuit, but that device may be daisy chained onto other multiple devices. If you don't test the entire chain, you may not realize that you inadvertently disconnected those other devices in the system until it comes time to trip, and it may not trip like it's supposed to. The other thing we recommend is printing and installing arc flash labels. And then during startup support provided in aiding in equipment to startup. If you have any questions about the relaying, about the changes, the control schemes, that's a good time to answer those when the operations personnel are actually in the process of starting up that equipment is usually when we see the most questions. We also recommend that you do in-service recording and validation of all current and voltage magnitudes and phase angles with the online equipment, and along with differential operating and restraint quantities for any differential relaying. From a final documentation standpoint, it's recommended to do as-built drawing packages along with updated ETAP SKM Easy Power model in its native manufacturer format. That way you can have it for your records and you can use it for whatever project you have in the future. Updated protection time current curves, incident energy analyses or arc flash results, relay settings calculations, and relay settings configuration database in manufacturer specific format. Again, if you ever have to go back to it in the future, you don't have to download it from the relay or get somebody to come on site to do that. You already have them handy. Along with a text description of the detailed relay operation, including how each relay element is set, the input operations, the output operations, and the IEEE guidelines used to develop the relay settings. Test sheets showing full test results for all the testing performed during the installation phase. And also customer-specific compliance documentation such as NERC for generating facilities or transmission facilities where these retrofits are performed. So a typical schedule for a single relay, keeping in mind again that we're trying to do a power system study, full approval drawing package along with customer approval prior to doing equipment procurement and delivery. Typically we would see that from a total duration of 20 weeks. Again, this is for a single relay, more of an overcurrent feeder application. Depending on the complexity, it may increase some of this time or it may decrease some of it. Order entry, kickoff / getting started typically takes a couple of weeks, with a power system study following approximately 1 week afterwards. Approval drawing package would take about 3 to 4 weeks, and customer approvals most of the time takes 2 weeks or less, depending on how set up you are and how quickly you're able to jump on it. We know you're fighting a lot of fires during your time on site, so we try to make sure that we plan for that during the process. Procurement and equipment delivery typically is about 8 weeks. Some components come in a lot quicker than other ones, depending on the manufacturer, your protective relays, and how in stock they keep their equipment. It could be as little as a few days to get the major parts of the relays. In some cases, though, we have seen it take up to 6 to 7 weeks, along with test switches, panel fabrication, etc. In-house assembly and testing usually will take a couple weeks from that point, and then on-site installation and testing is approximately 1 day. Depending on your system availability, maybe you can get that equipment back online later that afternoon, or if needed, maybe the following day for startup. For 20 relays, you'll see a very similar schedule with some increased durations for the approval drawing package and assembly and testing, and also for the installation and testing. Again, for order entry, kickoff, getting started, you'll usually see about 2 weeks for that process, another week for the power system study again, and then the approval drawing package, since we're going quite a few more relays, more than one, we usually see about 10 weeks to get an approval drawing package out. Customer approval, again, 2 weeks for you to review, comment, make any changes that we need to, and then we would proceed with procurement and equipment delivery, which could take up to 8 weeks. In-house assembly and testing, multiple panels, multiple people needing to work on them, multiple processes needed for the QC process, along with relay testing itself, can take up to 8 weeks. And then on-site installation and testing, we usually can do that in approximately 10 days. And then we proceed to startup. From a proposal requirement standpoint, in order to provide you a proper proposal, we would need a detailed scope of work, along with any customer equipment preferences. For instance, do you prefer a certain brand of relay manufacturer? Do you prefer a certain brand of test switches, certain type of control switches, lights, lockouts, etc.? And then we would also need some equipment elevation drawings. A lot of times, unfortunately, they may have some older electromechanical relays that are rather small, and these panels do get crowded sometimes. So whenever we're trying to put multiple relays in a single panel, along with multiple test switches, multiple new control switches, and proper spacing in between to be able to mount everything and wire it all out correctly, it can take up more space than the old installation used to. So we want to make sure whenever we do the proposal that we have enough space to be able to mount the new equipment. We also like to see the relay one-line diagrams, just to make sure that we're optimizing your system and recommending the correct protection. AC schematics, DC schematics, to get an idea of what type of part number we would need to use and how many test switches we would need to use. What type of control schemes might need to be taken out during the installation and demolition process. Along with connection diagrams, interconnection diagrams, again, just trying to get a better feel for your facility, get a better feel for your equipment, make sure that we're quoting the correct stuff. And then the equipment availability schedule is also a big one, especially whenever you start talking about more than one relay. Whenever we send out our teams, we do it in teams of 2 engineers at a minimum for safety and also quality assurance purposes. If a lot of times we can have those guys sitting in the same room and they can be wiring up on adjacent panels, or they can be separated by a small distance, but we want to make sure that we can properly do everything in a safe fashion, and we can also help each other whenever it comes time to take equipment out and put the new equipment in, hang panels, etc., without damaging anything. So that equipment availability schedule, if we find out that we have to mobilize 5 times because the equipment's not going to be available on a continuous basis, that can all make a difference whenever it comes to the timing of the project, making sure we can meet your needs from a schedule standpoint, making sure that we can get enough people out there. If you're trying to do a 20 relay retrofit project, for instance, and you're trying to do all of that in a single night, which has happened before, we need to make sure that we have enough people available, and we also optimize the design to be able to do that in a quick fashion. There's several options that can be done during the design phase, such that you're mounting a single panel with maybe multiple relays in it versus a single relay. All of that can be looked at during the proposal stage when we're trying to come up with a good decision, a good product that'll meet your needs. This next section is a proposal evaluations. A lot of times we get asked by people, well, how do we know what different customers, different vendors are providing to us? And we typically like to kind of guide them through with these questions and ask them to send these out to all the different vendors. And you can actually use this to kind of develop your specification also. For instance, in an approval package being provided for the customer approval, do you need to provide demolition meter and relay drawings? Do you need to provide demolition equipment elevation drawings, demolition AC schematics, DC schematics, demolition connection diagrams, interconnection diagrams? And maybe you need those in your application, maybe you don't. It's something that's recommended, just so you can always go back and see exactly what's being taken out in case something doesn't work properly whenever you get it all installed. Whenever it comes to getting AutoCAD drawings or redline drawings, different companies provide different things. One of the things you may want to ask them is how many meter and relay one line drawings are being provided. Equipment elevation drawings, AC schematics, connection diagrams, and interconnection diagrams showing all the new equipment that's being installed. Does the scope of supply include a complete bill of materials with specific part numbers? A lot of times we're going and we're trying to retrofit some old equipment, bill of materials aren't available, which means you're trying to guess. Or if you try to replace a control switch that has become frozen over time and it's been 10, 15 years down the line, a lot of times they don't make that anymore, or it's very hard to find the part number that's on that control switch or a different device. That's where this would come in handy. Does the scope of supply include updating the existing ETAP SKM Easy Power model to illustrate all the relay changes? Will the new relay settings be developed from existing relay settings, or will they be developed from scratch? A lot of times, especially with electromechanical relays, they have very limited capabilities. You're limited to basically one type of curve that the device comes with, along with the instantaneous. And maybe you can deactivate that instantaneous or you can't. So whenever we do these retrofits, again, we're trying to take into account your complete system and provide and take advantage of the new capabilities that the new relays can offer. Does the scope of supply include time current curves showing the new relay settings and associated downstream protection? That way you can visually see and make decisions on the best way to reliably trip your system during a fault. Does the scope of supply include an updated arc flash hazard analysis? If you're changing the time current curve, there's a very, very good chance that you're going to be changing your arc flash. Arc flash is based primarily upon the distance you are away from the fault, the amount of fault current, and the clearing time of the protected device. So if you're changing the relaying, you're changing the clearing time quite frequently. How many arc flash labels are being provided? You change the arc flash hazard analysis, have an updated arc flash incident energy, then a lot of times you'll also want to change your arc flash labels in the field. Does the scope of supply include the installation of those arc flash labels? If you're replacing 20, 30, 40 relays, you can have quite a significant amount of relay labels that need to be installed, depending on how the old protection was set up. And then finally, does the scope of supply include as-built drawings in an AutoCAD format, or are you just getting back a bunch of redline drawings? From a system design standpoint, ask people how many are they hooking up breaker 52A contacts to associated relays. This allows you to aid in event analyses and determine if everything tripped in the sequence that it was supposed to. Breaker trip coil monitors being wired up and programmed in the associated relays. Lockout relay position contacts, lockout relay coil monitors. And what this allows you to do is it lets you do some preventive analysis where maybe you don't have to get in there with meters on the system. You can do a quick glance at the relay with a light that comes on whenever it detects a breaker trip coil failure or a lockout coil failure, and you can quickly alert your operators and maintenance crew to get that fixed. From a test switch standpoint, are they being provided on all current inputs to each relay and on all voltage inputs to each relay? That allows you to simulate the system or isolate the system as necessary, or you can inject your own current and voltage during testing easily without having to modify the wiring and disconnect the existing system. Test switches provided on power supply inputs to the relays. Are test switches necessary on every trip output? Are test switches necessary on every discrete input to each relay? And then one question that we get frequently asked is, does the system design allow for complete relay isolation while the associated breaker is energized? For instance, you have a motor that goes out, that the relay goes out on, and that motor may be an integral process in your facility. Do you want to have the option to be able to pull the relay, send it to the manufacturer in the event of an issue, and still keep your motor running and still keep your process running? Does it allow you to perform maintenance while that equipment's running. A lot of times, some of these facilities, they run 24/7 and they don't want to take the time to take an outage just to test this equipment. If you do the test switch design right, a lot of times it is possible to still perform maintenance while keeping that equipment running with minimal risk. And then from a event analysis standpoint, is custom waveform capture configuration included? Is custom sequence of event reporting configuration included on all the relays? A lot of times what we'll see is the relay manufacturers have an out-the-box that basically puts in different inputs, it puts in different outputs, and it puts some basic signals in those event analyses capabilities. But what you want to do is you really want to tailor that to your specific instance. You may have voltages that are flickering between 80 and 90% whenever you're starting motors. Do you really want to see that event be generated every time that you see that voltage drop from a motor starting perspective? Or do you prefer to see it whenever there's actually a hard fault or a hard system issue that you can analyze? If you capture too much information, then what can happen is whenever you do have a significant event that you actually want the data from, whenever you go to start up or before somebody can get out there, that data may already be overwritten from all the additional information that you're trying to capture. The relays oftentimes have limited storage capabilities. So if you try to put too much in there, you'll end up with all the data being overwritten. From an equipment standpoint, identify the detailed relay part numbers to be provided. A lot of manufacturers nowadays, they have multiple options in the relays, and the price range can range anywhere from $950 up to several $1,000s per relay, depending on the specific application that's needed. So if you're trying to compare apples to apples on a quote and somebody comes in and they quote you the bare bones and it's really not what you want, you could get hit with either the equipment that you don't want installed or a rather large change order at a later time. The quantity of relays that are provided, how many test switches are to be provided, how many doors or relay mounting panels are to be provided. For instance, do you want the door to be completely replaced, or do you just want a relay mounting plate that covers up the old equipment and is mounted to the existing door? How many relay cover plates? For instance, you may have equipment that's located throughout the facility that you want to take off and demolish that's no longer being used. Do you want to take that relay out, you put a cover plate on it, or do you just want it to be flagged as out of service? There's advantages to disadvantages to both of those options. And then is everything provided to ensure a complete working system, such as terminal blocks, fuses, tie wraps, wire labels, etc. From an installation standpoint, will engineers be on site for construction? Is site-specific safety training provided for, or would that be something that would need to be done at a later time for an additional cost? Development of daily job safety analysis forms. Engineers on site for testing and startup, along with the lead engineer on site for construction testing and startup. A lot of times people may say they're sending an engineer out, but he may be someone that has no idea what's going on with the facility or with the retrofit to be performed. Are ring lugs provided on all terminations? SIS number 10 wire provided on all current circuits, or is it all SIS number 14 wire? Heat shrink wire labels provided on all wire terminations, and do the wire labels indicate the to and fro terminal locations on each end of the wire? Are nameplates being provided, and do those test switch nameplates show the specific functions such as voltages, current, A, B, and C, trip, etc. above each test switch? And is development a complete add-delete list being provided? From a testing startup standpoint, testing of relay analog to digital conversion included. That would be an A to D converter, injection of currents and voltages into the relay. Testing of relay inputs and relay outputs, function testing of all program relay elements. Secondary voltage injection testing on all modified voltage potential circuits in the field. Secondary current injection testing on all modified current circuits. Trip close testing included on all modified circuits. Is startup support included? If so, how many man hours are included? A lot of times it'll be said that you need to get it started up within a certain amount of time after the completion of the retrofit. That may be not able to be performed due to how you have your system set up or the outage that's in place. Is in-service validation of phase angle and magnitudes of all voltage and current measurements included to ensure that you're getting the proper signals and it's working it and everything's measuring correctly? Is documentation provided for all the tests identified above? A lot of times we get into a customer's facility and They may have no documentation, which means you're starting from scratch as far as trying to figure out what may be misoperating or may have failed to operate throughout the system. From a schedule standpoint, how many days on site will be required for the installation, testing, and startup of the complete system? I know a lot of times people are juggling outage schedules and they're trying to figure out, do we need to take a 1 week outage or a 1 day outage? So that can come in handy during the proposal evaluations. From a budgetary estimate standpoint, for a complete typical scope of work as shown on the previous slides, for a general purpose overcurrent type feeder that's feeding maybe a transformer or a motor, etc., you're looking at around $14,000, $20,000, depending on the complexity for small quantities of 1 or 2. And then for larger quantities, you typically get you get a little bit of an efficiency standpoint. You can bring it down the amount of time it takes to do so. And you're looking at about $11,000, $15,000 per general purpose feeder. Typically, engineering is about 50% of the total construction of the total cost, and construction, configuration, testing, installation, testing, startup, etc. is the other 50%. Some things that may increase that budget would be equipment availability for installation. For instance, if you're trying to do multiple relays and there's only one available each day, or if there's travel required, it may increase the amount of mobilizations. Are there advanced schemes such as fast bus protection, automatic transfer, maintenance switches, etc., that need to be installed? The cost of the specific manufacturer equipment. There's several different relay manufacturers out there, and some of them have more economical versions of relays than other ones. Some customers have very specific relays that they like to install because that's what they've installed everywhere else. So all that needs to be taken into account. And then field cables coming in, whether or not they want to be, you would like those replaced or not, or if you just want to limit the scope to the existing enclosure of cables. Some considerations that decrease the budget. Of course, doing more of these at the same time is going to be a little bit more efficient from a manpower perspective, from an installation, from a wiring, from an engineering perspective also. It's all going to decrease the budget, along with having standard protection designs and settings that you can apply over and over. Some reference projects that we've worked on. We've done some jobs for Entergy over at Lewis Creek in Willis, Texas. This one in particular was a turnkey relay retrofit, included all engineering, all procurement, all configuration, installation, testing, power system studies, etc., with Schweitzer 700 series relays. We also implemented a fast bus protection scheme on the power plant medium voltage auxiliary buses that drastically reduced their arc flash incident energy. Cost was approximately $300,000 for that. Over at Entergy Waterford in Kelowna, Louisiana, we did another turnkey relay retrofit on the utility power plant generator step-up transformers, and auxiliary transformers. Again, it included all engineering, procurement, configuration, installation, testing, and startup for approximately $230,000. Those were some pretty big projects with approximately, I want to say, 20 to 30 relays on each one of them. Georgia Pacific, this is one where the customer came to us and they had a very, very limited time frame to do the relays. We were able to do a turnkey relay retrofit, engineering, procurement, configuration, installation, commissioning, etc., with General Electric UR series relays. We were able to complete 51 breakers simultaneously in a single 18-hour shift. I'll be honest with you, that was a little bit of a challenge there trying to get all that done. It was multiple crews working in multiple locations, and it was a huge logistical challenge to do all of that at one time. The cost was approximately $381,665. We've done some jobs over in Beaumont, Texas. Again, turnkey relay retrofit, General Electric SR and UR relays, which are different platforms within the GE relaying system. Implementing islanding during faults. They have a generating system where they had frequent faults on the utility, and they wanted to be able to just island from them because the generator had the capability to fully handle the plant load. And they also wanted to upgrade the transformer protection on the industrial utility interstate substation. Noranda Illuminative down in Gramercy, Louisiana, wanted to do a turnkey relay retrofit again with GE UR relays on their generators. Here's just a sample list of some of the customers that we've worked with in the past. Not going to name each one of them line by line. Some things that can go wrong throughout your system. Who determines the exact equipment part numbers? There is a very wide discrepancy in hardware cost depending on the manufacturer you pick, the part number within that you pick, the platforms within the manufacturer that you pick. Have you considered the future of the protection schemes in your scope of supply? For instance, do you want to be able to implement future incident energy reduction schemes? Do you want to be able to communicate with these relays in the future? Do you want to copy the existing protection schemes, or do you want to leverage the full capability of the new devices? Do you want to replicate the existing installation wire for wire, or do you want to consider upgrading to the latest IEEE recommended protection schemes? Protection schemes have changed since some of these plants were built, especially if they were built back in the 50s and 60s. IEEE has looked at all the different deficiencies in the systems, and they come up with new recommendations. You may have simple overcurrent relays today. Do you want to include the voltage, the breaker monitoring, the trip coil monitoring, et cetera, in the retrofit project? Do you want to consider maintenance switches that are also integrated into the system? Do you want to consider fast bus systems? Do you want complete relay isolation via test switches to allow for fully testing and replacing the relays without requiring an outage? And then a lot of times we find that proposals are very difficult to evaluate from a variety of vendors. How do you ensure that all the proposals include the same scope of supply? And with that, that's basically the end of the presentation.
Wonderful. Thank you, Daniel. I appreciate that. That was a wonderful, wonderful presentation, very informative. I have the Q&A panel pulled up, and if anyone has any questions for Daniel, please feel free to type them in now. Daniel, do you guys primarily, we saw a lot of pictures of the finished product. Do you guys primarily deal with Schweitzer equipment, or do you have like some other manufacturers that you recommend as well?
So we have dealt with a variety of manufacturers. The pictures with the Schweitzer just happen to be from some of the relay retrofits that we performed recently. However, we deal with Schweitzer, we deal with GE, we deal with ABB, Siemens, Basler. There's all sorts of Beckwith, there's all sorts of manufacturers out there. And while we do have some recommended ones, if you don't have any specific manufacturers in mind already, we can have some discussions during the proposal phase with you about what the pros and cons are. Some of them have expanded capabilities, but also come with an expanded cost that may or may not fit your needs. But we can definitely work with a variety of manufacturers.
Right. Okay, great. Yeah, that's good to hear. I know some facilities probably have certain vendors that they are required to go with, right?
Absolutely. And in some cases, especially with generator protection or GSU, step-up transformers, where the generating facility connects to the grid, a lot of times NERC and FERC and those different entities, they require different manufacturers, and the insurance company also requires different manufacturers, just from a redundant standpoint.
Great, yes. Just to reiterate, the tests that are performed, like when the project is over, the customer will receive a report of all of the tests that were performed and all the updated diagrams and everything, right?
Correct. What we do is we go out there and we have a laptop where we have pre-printed copies depending on what's going on in the field, and the engineers run through each test and they initial each line of that test. For instance, if you're performing control circuitry, it'll say open test switch. The engineer that's performing the test will initial that, and then it'll say assert output, deassert outputs, inputs, etc. And each one of those lines is clearly spelled out, almost as if it's basically a test plan that walks you through step by step along with the expected actions. So that's provided for both inputs, outputs, control circuitry, along with current and voltages. Right. And that lets you know if maybe you have a primary injection system issue, or if the issue is in the system that's being modified. It allows for that chance.
Right, great. One attendee asked, do we have a sample documentation or report that we can provide? That answer is yes, Daniel, right?
Absolutely. Just reach out to, are we going to be sending out references if somebody wants to contact us?
Oh yeah, absolutely. At the end of this, after we're over finished today, I will send you guys a follow-up email with a link to our recorded session, because this is being recorded in case you guys want to go back and reference some of the information Daniel provided. But we can definitely, if you could reply, it'll come directly to me and I can get you over any sample documentation that you would be interested in looking at. We do have another attendee that's asking, on a large retrofit job, how many techs are typically assigned to a panel?
So what we do is a lot of times we're limited by the physical space where we're trying to do the installation. For instance, if you're in a typical, medium voltage 5 kV, 15 kV switchgear lineup, you only have 36 inches wide that you can physically fit somebody in. So we'll send 2 techs out, and we do have efficiency built in where we can work with 2 people on a single relay, but it's much more efficient whenever we can tag team on 2 relays at a time in different locations.
Mm-hmm. So do we provide, someone else asking, we provide union labor, or can you provide bonding on public power utility projects?
So typically we perform the installations with our own personnel here in-house at inoLECT. We send the engineering team. And so that consists of the lead engineer. It consists of engineers that are also familiar with these types of projects. Engineers don't really have very many unions that they can join. And because we're doing it with engineers versus the unions themselves versus electricians, we usually don't have union involved. Mm-hmm. We have had some facilities that came to us and said that they needed to provide union labor due to different rules and regulations. In that case, we typically subcontract out the installation to the union, and we send out the lead engineer to be on site to supervise the union while they're doing the work and answer any questions. The beauty of our package that we do is once it gets sent to an IFC stage, it really can be performed by a union with proper supervision, or it can be performed by our engineers.
Okay, and what about the bonding for public power utility projects?
That's something that we have encountered in the past. That's on a case-by-case basis, depending on what type of bonding needs to be performed and how much the cost is.
Yeah, okay. What are some of the most common pitfalls that you've seen with projects like these?
So the most common pitfalls that I've seen, and one of them is a very common one, is, you send out a very limited scope. You contact multiple vendors and you basically say, I want to retrofit the overcurrent protection on this feeder. And it consists of electromechanical relays. Well, you'll get all kind of quotes back. Some of them will basically come in and they'll say, yeah, we'll do it for X price and it's going to take us 4 days on site. Because what they do is they order a very, very basic relay, no test switches. They show up with a spool of wire. They show up with some lugs. And they show up with a relay. They demolition the existing stuff, not taking any record of what was demolished. They put whatever holes are necessary in the new panel. Hopefully they can cut straight with a ruler or something like that. Sometimes it's pretty hard to cut straight with a jigsaw. And they just put the new relay in and they wire stuff up with no documentation whatsoever. And then you get the other side of it, which is you're trying to provide a fully engineered package with all proper documentation, updating the ETAP model, and providing a relay configuration that doesn't just match what is out there in the field. We've had some relay manufacturers come in and say, oh yeah, we can match that curve, no problem. Well, those curves never match up exactly the same. And so that's why we encourage people to have either a trusted partner that they work hand in hand with to develop a full proposal that matches their expectations, or they have some kind of specification that basically walks through each one of those proposal questionnaire questions, and it gives the answers to the vendors to make them all fall in line with your expectations.
Right. Well, so what kind of consulting services are done on the front end that will help a customer kind of specify their project?
So from a consulting standpoint, you said if a customer has already specified the project?
Well, it's kind of to help them specify the project properly. I guess help them determine what exactly needs to be done.
Okay, so from a consulting standpoint, what we would typically do on a consulting job is we would get with you. We would talk about your specific facility needs, what you're trying to accomplish. For instance, maybe you have a need to perform maintenance testing on a 1-year interval, but you can't take your system out but every 3 or 4 years. That's something that needs to be taken into account. You may have some expanded protection that you're trying to implement. Maybe you're trying to reduce your arc flash in your facility. Maybe you're trying to implement some remote operation where maybe you push a button on the front of that relay, walk away, and then 10, 20 seconds later, it opens or closes that breaker. You may be wanting to implement communication schemes throughout the facility so you can open and close breakers and see relay status from across your plant without having to leave your office or the operator control room. These are all the kinds of questions that would go into the consulting stage to help you conceptualize the system and develop a full specification. That specification would have full part numbers for everything. It would have full test switch part numbers, A lot of times what we would recommend in order to reduce any confusion between vendors is that it actually have some relaying schematics of what would need to be provided on the panels. Maybe you have trouble locating the existing documentation in your facility, such as drawings, et cetera, and knowing which ones need to be provided to vendors. If you don't provide all the drawings, they may not take into account the fact that each relay might have to be individually changed and a common scheme can't be applied to it.
Mm-hmm. Right. Well, great. Someone is asking, what regions of the U.S. can you support with these types of projects?
This type of project we can support over the entire United States from a turnkey engineering. The only barrier there is typically travel. Sometimes it may not be cost effective depending on the actual installation schedule. If it's a large number, we can typically make one trip, then we can keep that travel cost down to a minimum. From an engineering perspective, from a consulting perspective, we can support nationwide and also internationally. We've done projects over in Australia and in Europe and in different countries overseas, in Canada, Mexico, et cetera, for them to do the installation themselves.
Right. Someone else is asking, does inoLECT only provide the turnkey services, or would you be willing to provide engineering the package and assistance to a preferred local contractor?
We can do it any way you want. There's engineering, there's specification, there's engineering, there's panel manufacturing, there's construction, and then there's testing and startup services. That can all be split out depending on your specific needs.
Because I'm sure, again, a lot of these customers probably have approved vendors that they have to, kind of do business with, right?
Absolutely. And in the case of the union, like one person posed a question about a union that they need to use, you may have unionized labor within your facility that says if any electrical work has to be performed by that union. That's not a problem. We can work with it in any way that we need to, up to the extent of giving you a package that's ready for them to utilize. And then it's up to you if you want us to come on site and help supervise or not. So,
do you offer relay testing services?
Absolutely. We can do that either here at inoLECT or we can do it on site at your facility.
All right. Well, wonderful. That was all the questions that I see popped up on our Q&A panel. But if you guys have any questions that you think of after the fact, you can absolutely get those into us. Like I said, I'll be sending out a follow-up email to all of our attendees today with a link where you can listen to the recorded session to reference any of the information Daniel has provided. I know Daniel and his team are doing a lot of virtual things along with our sales team today. Because of the COVID and everything that's crazy going on, a lot of facilities have restrictions about people coming on site, just to do presentations and such. So we can set up a one-on-one virtual call with you guys as well to kind of walk through sample projects and anything that you would kind of want to talk to Daniel or his team about. So with that being said, if you have any questions, our phone number you can always call is area code 225-751-7535, and the email address that'll come directly to us is info, that's INFO, @inolect.com. Feel free to always reference our website as well. We have a lot of informative information about our specialized projects and services that we perform. It's inolect.com. And if Daniel doesn't have anything else to add, I want to say thank you again for taking your time out of your day to join us for our presentation. And we hope you guys have a wonderful rest of your afternoon.